Hi students, greetings from MPower by Dr. NK. Today we are going to learn the chapter Chemical Kinetics. Well, before I start, I would like to draw your attention to the reactions which are happening around us. You have seen many chemical reactions happening around you. Have you seen the food getting spoiled? Iron getting rusted, or a fuel getting burned in an auto engine? All these are chemical reactions. Now, when we learn chemistry, we need to learn three things about a chemical reaction. The first is whether it is feasible for this chemical reaction to happen or not. And the second one is the extent to which a reaction can proceed. The third is the speed at which the reaction will take place to reach equilibrium. Now, let us take each factor and see which branch of chemistry can help us to understand this. The first one, the feasibility of a chemical reaction. That means whether a reaction can really happen or not. For example, you take a piece of paper and place it on a table. You know that a lighted matchstick can burn the paper. But let me ask you a question. I keep the paper, I keep the matchstick, and lo, can I say that the paper is getting burnt? Will it get burnt? What's the missing factor? The fire. The ignition of the matchstick is missing. So the paper doesn't get burnt. And we can see that it's not just the ingredients which are required for the reaction which will determine whether it is possible or not. It is also the conditions at which this reaction can happen. And therefore, we have to consider all the conditions which are required for the reaction to reach equilibrium. Now, whether the reaction is a possibility or not can be predicted by thermodynamics. And you all know that when delta G is lesser than 0, at constant temperature and pressure, then the reaction is feasible. The second one, the extent to which a reaction can proceed, can be determined by chemical equilibrium. And the third, the speed of a reaction, that is, the time taken for the reaction to reach equilibrium, can be found out through chemical kinetics. Kinetics not only helps us to determine the rate of a reaction or the speed at which the reaction takes place, but also helps us to describe the conditions at which these reactions can take place, and also the factors which affect the rate of a reaction. If you consider the factors, there are a few factors which you can consider. The first is the concentration of the reactants. The second is the temperature. The third is the pressure. And the fourth is the catalyst. Now, at the macroscopic level, we are interested in finding out the amount of reactants that have reacted or formed and the rate of consumption of reactants or formation of products. But at the molecular level, we are interested in finding out the reaction mechanisms involving orientation and energy of molecules undergoing collisions. Now, in this chapter, we are going to deal with the average and instantaneous rate of reaction and the factors affecting these. Are you ready? And do you have any doubts? If you have any doubts, do not hesitate to post your questions in the comment box and I'll be back with you to clarify your doubts. Now, let's go to the rate of a reaction. We all know that some reactions take place very fast and some reactions are very slow. For example, if you take a mixture of an aqueous solution of silver nitrate and sodium chloride, when you mix the two of them, instantaneously you can see a precipitate of silver chloride being formed. The white precipitate appears like magic. The reaction is so quick. On the other hand, if you take iron getting rusted, it takes a long time and you don't even realize that the reaction is taking place. Am I right? Now let us define the speed of a reaction or the rate of a reaction. What is happening during a reaction? The reactants are getting converted to products. Am I right? Now let's take R as the reactant, hypothetically, and P as the product. Now in this, if we have to define the rate of a reaction, we can find out the rate by observing the rate of decrease in the concentration of the reactant or the rate of increase in the concentration of the products. Why am I saying this? What is happening during the reaction? The reactant R is slowly getting converted to the product P. So, R is getting consumed, therefore, the concentration of the reactant R goes on decreasing, whereas product P is getting formed. Therefore, the concentration of the product P is increasing. And hence I am defining the rate of a reaction as the rate of decrease in the concentration of any one of the reactants or the rate of increase in the concentration of any one of the products. Is it clear? Now, let us take a deeper look into this reaction. Let us say the reaction has just now started and at time t1, let R1 be the concentration of the reactant and P1 be the concentration of the product. I am using square brackets here to represent molar concentrations of R and P. Alright. Now let us say some time has elapsed and the reaction is at time t2. Now let the concentration of the reactant be R2, which is represented by square brackets R2, and let the concentration of the products be P2 at time T2. Now, can we write this as a mathematical equation for the rate of a reaction? It is very simple. The left hand side of the reaction is a rate of disappearance of R, which is equal to decrease in concentration of R divided by time taken. Now let us see what is decrease in concentration of R. What was the concentration at time T2? R2. Concentration of R at time T1 was R1. Therefore, delta R, which is the decrease in concentration of R, is given by R2 minus R1. Alright. Now you substitute this in the equation. Rate of disappearance of R is equal to minus delta R by delta T, where this minus sign indicates the decrease in concentration of the reactants. Similarly, we can write the rate of appearance of the product P. What is that equal to? Increase in the concentration of P divided by time taken. Now let us see what is the increase in concentration of P, just like we did decrease in concentration of R. Delta P equals P2 minus P1 and delta T is as usual T2 minus T1. Therefore, rate of appearance of product P is equal to plus delta P by delta T, where the positive sign indicates the increase in concentration of P. Now if you take equations 1 and 2, they represent the average rate of a reaction RAV. And I'm sure you are very clear with this equation. If you have any questions or doubts, just post your questions in the comment box and I will answer your questions. Also, don't forget to like, share and subscribe to my channel, and of course, not to forget downloading MPower app. See you soon.